folks, and welcome to another set of 8th grade science video notes. Today we're going to learn all about the atom. You may have learned before that all matter is made up of atoms. Matter is anything that takes up space and has a mass. For instance, you take up space and you have a mass, so you matter. Many years ago, even before I was born, scientists and philosophers thought about matter and what it was made out of. Around 440 BC, there were two philosophers who had two very different ideas about matter. There was Aristotle, who believed that matter was made up of the four elements, earth, wind, fire, and water. And then there was Democritus, who thought it might be a little bit more complicated than that. So sitting in his toga on the steps of the Parthenon, I assume, he wondered how many times could you split something in half? He decided that at some point you're going to run into a piece of matter that you can't cut into half anymore. He came up with the Greek word atomos, which means particle that cannot be divided anymore. And today we use the word atom. This was a really radical idea at the time. Aristotle, who was a lot more popular than Democritus, didn't really like Democritus's theory. He figured a particle that small would be too small to see, so if you can't see it, it doesn't exist. Eventually, we did come around to Democritus's idea, and for the most part, he was actually pretty close to being right. In the early 1800s, John Dalton came around, and he wrote a formal scientific theory on the atom. We refer to it as Dalton's atomic theory. Dalton said that an atom is the smallest particle into which an element can be divided and still be that element. His theory also stated that all atoms of a particular element are exactly identical to each other, and that all matter is made up of atoms, and you can't divide matter into anything simpler than that. The important thing to know about science is that scientific theories can be revised if we find new evidence. For example, through various amazing experiments by scientists like J.J. Thomson, Ernest B. Rutherford, and others, we found that there are particles that are smaller than the atom. We call these particles subatomic, which means they're smaller than an atom. These three basic subatomic particles are protons, neutrons, and electrons. When we think of an atom, we have to think on a very tiny scale. For example, there are approximately 20 sextillion, that's 21 zeros after the 20, atoms in every single penny. If it helps, that's 3 billion times more atoms in a penny than there are people on Earth. The atom is made up of two parts, the nucleus, which exists in the center of the atom and holds all of the atom's mass, and then there's the electron cloud, which exists around the nucleus. So, our three subatomic particles, as you already know, are the protons, neutrons, and electrons. Protons exist inside the nucleus. They have a mass of 0.0000000000000000000000017 grams, and a charge of +1. Their mass is so small, and we really get tired of writing those 24 zeros before the 17, that we came up with a whole new system of measurement to describe subatomic particles' masses. So instead of grams, we use the atomic mass unit. An atomic mass unit is equal to the mass of one proton. So in other words, a proton weighs one atomic mass unit. If it helps to remember the charge, which we said was +1, protons are positive. Neutrons also exist inside the nucleus right next to the protons. They also have a mass of 1 AMU, but they do not have a charge. They're neither positive nor negative, so we call them neutral, or we say that they have a charge of 0. If it helps to remember the charge, neutrons are neutral. Electrons exist outside the nucleus within the electron cloud. These little boogers have a mass so small in comparison to a proton or a neutron that we say its relative mass is 0 atomic mass unit. They have a charge of -1 and help to balance out the positive charges from the protons. There are two numbers that we might use to describe an element. There's the atomic number and the mass number. Each element on the periodic table is specifically identified by a unique atomic number. That's always equal to the number of protons that there are in a nucleus of an atom of that element. You might have noticed when you were working on your building an atom simulation that each time you added or subtracted a proton, you not only changed the atomic number, but you changed the name of the atom. So the atomic number is very specific and it only goes with that one element each time. So hydrogen is always atomic number 1. Helium always has an atomic number of 2. We also have the mass number, which is just the relative total mass of one atom of an element. So remember that protons and neutrons both have a mass of 1 AMU, and electrons have a mass of 0 AMU. So when we look for the mass number, we could describe it as the number of protons and neutrons in the atom. Or we could just do protons plus neutrons, and that gives us the mass number. Anytime we have an atom, we have an exactly equal number of protons and electrons. That's actually one of the definitions of an atom, that the overall charge is 0 or neutral. If we have an unequal amount of protons and electrons, then we no longer have an atom, we have what's called an ion. An ion is just like an atom, except it has a non-zero total charge. So remember that protons are positive 1 and electrons are negative 1. There's two ways you could do the math to find the net charge of an ion. You could add 1 for every time you have a proton, because protons are positive, and then subtract 1 for every time you have an electron, because electrons are negative. Or you could just take the total number of protons minus the number of electrons. If you have more protons than electrons, then your charge will be positive. If you have more electrons than you do protons, then your charge will be negative. Well, that's all for today, folks. I hope this video helped you to understand a bit more about the atom.